So in this series of videos about graphs of related functions, given a graph of a function y equals f of x, the following transformations are going to describe how to sketch the related function. So what happens if our related function is y equals negative f of x? We're going to get a reflection in the x-axis because we're going to invert all of our y coordinates. So the graph of y equals negative f of x is a reflection in the x-axis of y equals f of x. So all of our x coordinates are going to stay the same, and our y coordinates are all going to reflect in the x-axis and become their negative equivalent. So let's look at how y equals f of x, being this curve, is going to have the graph of a related function of y equals a negative f of x. So let's mark on our key points. So we've got three roots, we've got a maximum and a minimum stationary point, and we've got a y-intercept that we're going to consider. And the transformation that we want is y equals a negative f of x. So what's happening? We're going to be putting all of our y coordinates to the negative equivalent. So all of our roots have a y coordinate of 0, so they're all going to stay where they are. And that's why this reflection occurs in the x-axis. Our negative 2, 2 is going to become negative 2, negative 2, because we're reflecting that maximum turning point to become a minimum turning point of our related curve. Now, we're going to move our y-intercept down from 0 1/2 to 0 negative 1/2. And we're going to move up our minimum stationary point to become 3 1/2 positive 3. And then we need to sketch in our curve through those points, and so you can see that we've got our reflection in the x-axis. So in general, the graphs of y equals negative f of x is a reflection in the x-axis of our y equals f of x original function. So what would happen to the graph of our related function y equals f of negative x? So this graph of y equals f of negative x, or the function of negative x, is a reflection in the y-axis. So this time our y coordinates are going to stay the same, and our x coordinates are going to become their negative equivalent, reflecting in the y-axis. So let's look at how the graph of our related function y equals f of negative x is going to work. So let's consider y equals f of x again, and sketch in our curve and mark on those key roots, y-intercepts, and stationary points. And we want to work out what y equals f of negative x is going to look at. So this is the function of negative x. So that means that that y-intercept is going to stay exactly where it is because we're reflecting in the y-axis, because f of negative 0 is just the same as f of 0. Then we need to consider the rest of our points. So negative 4, 0 is going to move to 4, 0. And our negative 2, 2 is going to move and reflect on that y-axis to 2, 2. We're then going to shift our other roots from the other side, and our minimum stationary point is going to be a minimum stationary point on the opposite side of our y-axis in that third quadrant. And then we need to sketch in our curve so that you can see we've got our reflection in the y-axis. So in general, the graph of y equals f of negative x is a reflection in the y-axis of y equals f of x. So you can see that our y coordinates are all the same, but this time our x coordinates are the negative equivalent. So what about y equals negative f of negative x? Well, there are two ways we can approach this. We could apply our two combined transformations, and we could reflect in the y-axis and then reflect in the x-axis. But we can also think about this as a rotation about the origin. So our points are going to rotate in a half-turn rotation about the origin of y equals f of x. So let's look at how we would graph our related function in this case. So we're going to start with y equals f of x. And this would actually be y equals x minus 4 all squared plus 2, because we know that it's related to our x squared curve and it has a minimum turning point of 4, 2. But this again works for any function of x. So we want to graph y equals negative f of negative x. And we want to rotate it about the origin, which I've now marked on. So that means that that turning point has to stay the same distance from the origin as it rotates around to a half turn. So you can see that we've moved through the fourth quadrant and finished in the third quadrant, and our minimum turning point has become a maximum turning point of -4, -2. So in general, the graph of y equals negative f of negative x is a half-turn rotation about the origin of y equals f of x. Now, if you don't remember that particular related function, you can break it down into a combined transformation using your knowledge of y equals negative f of x, which is our reflection in the x-axis. So that would have taken our 4, 2 minimum turning point to be a maximum turning point at 4, -2. And then you could have applied your f of negative x knowledge, knowing that that's a reflection in the y-axis. And so you would combine that to end up with your y equals negative f of negative x, with your turning point moving from 4, 2 to -4, -2.